So we are starting chapter 3 today. This is 3.1, relationships between lines. A lot of the stuff we're talking about today, we've already talked about. It's just sort of putting it all together in one organized space of notes. We'll do some examples you can see on the board. We're going to get about halfway through the lessons for this chapter. We will review on Thursday. Friday is hobo day. However, this is a lunch hour, so it doesn't affect our schedule at all. So we can still get the quiz in on Friday and then no homework over the weekend. So parallel lines are lines that lie in the same plane and do not intersect. On a picture, they are lines that run the same distance from one another the whole time. That's how we ensure that they're never going to intersect one another. And they have these arrows on there. So even if they look parallel, you can't say like, oh, they're parallel because they look parallel. They have to be labeled parallel, okay? And then the symbol looks like that, almost like an 11. I don't know. When you write it, it's just like two straight up and down lines, okay? Like a tiny little set of parallel lines. This would mean that line M is parallel to line N. So fill in all this information in your chart, and then we'll move on to the next type of lines. So perpendicular lines are lines that lie in the same plane and intersect to form right angles. So in a picture, we've seen this before, it's the little box. That means that that's a right angle, which means that the lines are perpendicular. And then there's also a symbol for this one. It always reminds me of an upside down capital T. So that would mean that line M is perpendicular to line N. So skew lines are easy to confuse by definition with parallel lines because they're both lines that don't intersect. The difference is that these are lines that aren't even in the same plane. So if you see this example, if you have like a flat surface with a line on it, and then like way over here there's a line shooting through the surface, those would be examples of skew lines. They're not parallel because they're not on the same flat surface, the same plane, but they're also not going to intersect. So I always like to think of like a highway overpass, you know, where one road is going under the other one. They're not intersecting. You know, you can't get from like one road up to the next by like making a right turn, but they're not parallel either, okay? They're just lines that are totally like not even on the same level, not on the same plane, never going to intersect, kind of have nothing to do with one another. Those are skew lines. So we're supposed to use the diagram below to determine if the lines are parallel, perpendicular, or neither. So kind of like a matching almost. 3 options: parallel, perpendicular, neither. I am going to use those new symbols that we just learned. So for parallel, I'm going to put that. For perpendicular, I'm going to put that. And then neither, I will just write the word neither. Okay? This is one where I think highlighting would be a really good idea. So line N and line M. So N is here, M is here. What's the relationship? Parallel. They are parallel. So you can write the word parallel, or you can use the symbol for parallel lines. All right, next. Line A and line B. So A is here, B is here. Neither. They do intersect, but not in a way that makes a right angle. So that's a neither. All right, next, A and N. So A is here, N is here. Those are perpendicular. You can see there's a box where they intersect right here. I've kind of covered it up with all my highlighting. Perpendicular is like that upside down T. All right, line N and line B. So N is here, B is here. That's a neither, good. And then the last one on this example says that A and M's. A, M, those are perpendicular, good. All right, questions? The key here is to imagine this as a 3D picture. So A is the flat plane. It's like a piece of paper, right? Line L is on the piece of paper. Line K is on the piece of paper. And line M is like shooting through the paper. It is intersecting L. You can see because there's a dot there and because they're solid when they go towards each other. See how it's dashed right here?
Yeah.
So that's not on the plane. That's like behind the plane.
Yeah.
So it's not actually touching K.
Yeah.
K is like closer to us. And M is just going straight up and down a little farther back. So are K and M skew or not?
No skew.
Yes.
They are skew because skew means they don't intersect. Okay, so yes, the lines are on different planes and don't intersect. What about L and M?
No.
Those are not skew. Those lines do intersect right here. And look, they make a little box, so they're actually
What do these words mean?
they're actually perpendicular. Thank you.
Young money.
Any questions? So it says, use the diagram below. Name a pair of parallel lines. Line X and line Y, you can tell because of the little arrows. The arrows mean parallel. So line X and line Y. If you want to write the word line X and line Y,
So we can't write those.
you could write it like this, or you could write line X and line Y. Yeah, or you could write, yeah, that's a good way to do it too.
What you write?
She wrote, let me write it up on the board. So X is parallel to Y. That works good too. I actually probably prefer this way. Way to go. All right, name a pair of perpendicular lines. Z and X, yes. So line Z and line X. Again, if you want to use the symbols, you would say like Z perpendicular X. And then a pair of skew lines. Z and Y, yes. Y is up front by us going side to side. Z is a little farther back going up and down. So those are skew. Any questions?
Oh.
So, first one you see on the board is parallel planes. I love this definition because there's so many food-related examples. I don't know. I just ate lunch, so I'm not super hungry right now. But, you know, anytime I can bring food into it, just makes me happy. So, two planes that do not intersect. A very good example of two planes that do not intersect are the floor and the ceiling. Okay, that's not very exciting. I like to think of parallel planes like the bread on a giant club sandwich. You know, like you got your bread in the top, you got some bread in the middle, you got some bread on the bottom. They don't intersect. There's a bunch of stuff in the middle. You know what I'm saying? They're running just right alongside each other, not going to touch. Or, you know those, they're like kind of cheap cookies. They're like long rectangles. They're called like wafers or something. They come in brown and yellow and pink. Those are really good examples of parallel planes because there's all the layers, you know? Yeah, they're good. Or like just a basic one would be like an Oreo. Like the two brown cookies of an Oreo. Those would be parallel planes because they're not going to touch. Okay? Now, a line perpendicular to a plane. This one's a little less fun. Not a lot of food examples here. Ooh, maybe the toothpick going into the club sandwich with all the parallel breads. There you go. So it's a line that intersects a plane at a point, and it's perpendicular to every line on the plane that intersects that point. So you have a plane, you have a line, the line makes a bunch of 90-degree angles with the plane. We are going to use the diagram below. Name a plane that appears to be parallel to plane B. So here's a plane, here's a plane, here's a plane. We got a line going through these two. We got a line on plane B. We've got a line on plane C. Which two planes... which one plane is parallel to plane B?
Plane C.
Plane C, it looks like they're kind of stacked on top of each other like a floor-ceiling scenario.
Yeah, right.
So yes, plane C. Now I want to name a line that appears to be perpendicular to plane B. So plane B is right here. What's a line that makes a right angle with this plane? Line L. So again, you could write line L, or you could do L with the line symbol. I'm not a big fan of this. I feel like you need 2 letters underneath to use this arrow, but another geometry teacher wrote this. I'm going to go ahead and trust it. There you go. Questions? All right, here is number 5. Think of each segment in the diagram as part of a line. Use the diagram below. So imagine like this is actually a line and not a line segment. It's going on and on. This one's going on and on and on. Okay, that's what the directions tell us to do. Name a plane that appears to be parallel to plane VWX. VWX. So it's like, if you're looking at like a box, it's like the side of the box. Which one appears to be parallel?
SRT. VUX. No. SRT.
SRT. Yeah, any of these 3 letters over here would work. So QRS or SRQ or RST, any of those 3 letters, this plane. They're like the sides of a box, okay?
So
Name
if I
a-
had RST, that would okay too?
What?
If I had RST, that would be okay.
Mm-hmm. Just, yeah, put the word plane in front of it, but yes. Number 2, name a line that appears to be perpendicular to plane BWX. So I feel like these are getting a little crazy. Let me get my highlighter back out. VWX, so this same guy over here.
RST.
What's a line that appears to be perpendicular?
R.
TXSW.
Q what?
U.
Curve.
QV would go this way.
Q.
We wanted to make a right angle with the side of the box.
So that one right there, you see the line right there? What's the name of that?
UV.
This one?
Yeah.
That's right on the box.
That'll be UV.
What is it?
UVW.
R. You got to drop one of those letters.
QT.
QU would work, yes. A line only needs, if it said a plane, you would be right, but we just want a line, so just focus on 2 of the letters. QU would work. Other ones that would work would be SW, this one back here, or TX, this guy back here. You could use RV, but there are 3 that are labeled with the right angle, so I would go with those before doing one that might not. But it does say which ones appear, so you could use it even if there wasn't the box. All right? Again, the key is to just imagine these as actual 3D models. You can't just picture all these points like plopped right on top of each other. All right, that is it for today. So I'm going to give you guys your homework. You have the rest of class.